So, on behalf of the Geodata and Knowledge Working Group, I would like to welcome you all to the second dialogue of the 2026 dialogue series. So, this one is focused on interoperability across domain, looking at in-situ, satellite, and citizen science. So, we're going to hear from a lot of speakers today. And this webinar comes at a time where we're working on the in-situ strategy implementation for GEO. The strategy will be presented later today, but one of the items considered under the strategy are the potential roles for GEO and its members in the in-situ landscape, particularly the role of coordinator, where we highlight that we want to actively engage with stakeholders to encourage greater reuse of in-situ data. And we see this dialogue as contributing directly to that effort. We have an impressive panel, as mentioned, ranging from citizen science, satellite data, in-situ, and standards and interoperability. There is one minor change I would like to announce in the speaker lineup. So Helen will be unable to present the in-situ strategy, but Marie-Françoise Voidrot will step in on her behalf and cover that strategy. So there's just that one change in the agenda. We'll start without further ado, about the role of citizen science in Earth observations, particularly use cases from the Enforce project, so citizen science at a local scale. Our first speaker is Linda C., who will cover the topic on citizen science and the Earth observation ecosystem. So, Linda, whenever you're ready.
Okay. Thank you very much. Yeah, as introduced, my name is Linda C. I work at the International Institute for Applied Systems Analysis, and I'm going to give you a very quick overview on citizen science and Earth observation. I'm just going to move that. Okay, so citizen science, crowdsourcing, volunteer geographic information. I think these are terms that many people are aware of. There are other terms, and they've emerged from different disciplines, but in general, they generally refer to the involvement of citizens in knowledge generation. And I think the collection of data is certainly one of the most common forms. But then at the same time, we know that one of the biggest challenges in Earth observation is the lack of in-situ data or ground truth data. And this is where citizen science can play a big role. So it can provide data for training, for validation, and it can be part of this satellite to product generation workflow. So for example, ground-based data collection or in-situ data, or it can also include visual interpretation of satellite imagery, so labeling and annotation. And we've developed various tools at EASA for doing this. And then compared to traditional sampling, this of course can be at a much higher spatial resolution, so you can have much denser samples. It can be much more frequent than traditional sampling, and it can also have a much richer thematic quality, for example, in OpenStreetMap. And then quickly on the right, this is just an example of a crowdsourcing campaign that we ran at EASA. It was to involve citizens in collecting data on field size, agricultural field size. And this map just gives you an idea of the volume of data that we collected in 4-week period. Okay, so very, very powerful way of collecting training and validation data. Okay, we've developed other tools to support Earth observation. I talked about GeoWiki, but PicturePile, this is a mobile-based application where you can very rapidly classify images, satellite images or photographs. So here we have, do you see tree loss over time? You see 2 satellite images before and after, and then the citizen would swipe the image to the left or to the right, depending on the answer. Then we have our in-situ mobile-based application. This is called PhotoQuest. Originally, it's for land cover, land use data collection, but now it's been brought into something called GeoQuest. So basically, any kind of field-based in-situ data collection can be done with the app, and we're using it in the Enforce project. So this is my final slide just to introduce this project. It's a Horizon Europe project for 4 years. The overall aim is to demonstrate the use of citizen science for environmental compliance And there are 8 case studies across Europe. You see them on the map on the right. And my role in that project is to provide support on the citizen science data collection tools. And the case studies cover things like the identification of illegal activities, so fires, deforestation, air, water and soil pollution, biodiversity loss, land clearing, waste dumping, etc. So quite a range of different topics. But the secondary aim is to integrate Earth observation into this process. So that includes Copernicus as well as commercial services. So working with ERSC, who are a partner in the project, we've been identifying different Earth observation use cases that can complement the case studies and the citizen science. So for example, we're looking into integrating deforestation alerts from Earth observation into the GeoQuest mobile app that I very briefly showed you. And then citizens could verify those deforestation alerts or fire alerts on the ground. Another example is identification of changes in ocean color as an indicator of pollution, again, using a Copernicus service for that. So there are different Earth observation case studies being integrated within the Enforce project. So I realize I was incredibly brief, but now I would like to turn over to my colleague Vanessa, who will talk about the case study in Barcelona and possibly the data readiness levels that are being developed as part of Enforce. So I'll stop sharing and let Vanessa share.
Maria Jose, if you are ready to present the case study on safeguarding Barcelona urban beaches through the engagement of citizen science, please, you're welcome to share your screen, and then we'll return to Vanessa.
Okay, thank you. The study case of Barcelona is about the coastal areas, urban beaches, and I like to present our organization, Barcelona Water Cycle. Is the public entity that manages the entire water cycle in the city of Barcelona. And we work with all the public operators of water at the European level, national and Catalan. Also collaborate with international organizations for global justice and cooperation. We try to participate in European projects because for us it's crucial to have the best technology, the best solution for the management of the water cycle. In the municipality of Barcelona, it is also very important, the citizen engagement. There is an office specialized in and that integrate all the citizens projects, citizen science project and community science projects in the city. And this organization also helps our Enforce project. And Barcelona is interested in have the best tools and all the things that can help to have this commitment with citizens, because every day we have more environmental problems. And there is a tool that you can consult. This is very important for us. It's Barcelona in your pocket. It's an application, and with this tool, all the citizens can have suggestion, compliance. I don't know, all the things that can communicate with all the municipal organization. Is a safe way to have all this communication with citizens. Okay. The Enforce study case of Barcelona deals with the urban beaches that are at these times with in the case of Barcelona, and I think all the cities with beach around the world, the problem of the decrease of marine biodiversity. Also, the problem with the residue, the waste of the products of tobacco. Instead, in Barcelona, we have a campaign started a decade ago, but officially 2 years ago. Is Barcelona beaches without smoke, and is a very important achievement that our city has. But also near these places, we have a lot of problem of this waste in our city. There are a lot of policies to try to reduce this problem, but really it's a huge problem for us. And there is another problem about the wet wipes pollution. In our case, we have a combined sewer system. In the same infrastructure, we have the rainwater and also sewer wastewater. And when we have rainy episodes, we have this problem with combined sewer overflows and all these things. Wet wipes are an improper waste inside the water cycle. And we need that all the sectors of the society know this problem, because sometimes the product is not very well explained. All the labels in this product are not enough clear without the management of this waste. Okay, and we need to focus on these problems. And citizen science are science projects are a good opportunity to involve all the sectors, all the, I don't know, it is a good learning with a service for the city. Okay. And with the three cases, we have different levels of maturity and conditions. Okay. Biodiversity citizen science projects are now very mature in our city. There are a lot of tools, a lot of platforms like Minca that are working very well. And with this, all this work, Barcelona has now an atlas of biodiversity that integrate of all this kind of information. And also in this case, is a bioindicator about the health of our bathing waters. We have also this new case with the campaigns for the evaluation of the problem, and also protocols to have this strong data with citizen science using existing tools with other previous projects like Marnova, that is very new in all the marine waste products in beach in the sand. And there is this new study case. I have this week a news about that in Scotland in next year there will be banned all kind of wet wipes. There is a good news for all of us, because I think it is a increased problem, a lot of money, a lot of environmental problems, because all the in our coast there is underwater a lot of impact for these waste and the products that there are in this kind of hygienic products. And I think maybe there will be the unique way to solve this problem. But if we have the current European legislation, we need to almost evaluate the problem, focus on the methods and the protocols to have this kind of the register of citizen science. And at this time, there are also a lot of studies to have the responsibility, standards producer responsibility, And the government of Catalonia is asking us to help about the cost of this extended producer responsibility, because sometimes in this kind of diffuse waste, it's very difficult to have all the impact at all the environmental damage and have the conversion with the euros that cause all the problem. And for us, for the municipality of Barcelona, this new study case with wipes, we are very, very interested in all the results, and it's a good opportunity to have this collaboration, this geo information about this problem that we have also at this time. We have only a part of the picture, and with a lot of data and with good quality for the help of this project, could be very important for us. And we have a previous project, iBath Water, and with this project, it was a good opportunity to have all the contribution of IF's waste in the combined sewer overflows waste, and the 80% of the improper waste is wet wipes. Okay, there are other kinds of waste, but there are natural leaves and other things. Okay? And it could be, it will be new in this project, all the collaboration with underwater schools and scuba diving that we have in Barcelona, to have these pictures underwater, because there are a lot of projects evaluating this kind of waste in the sun, but inside water there will be a very interesting records and data for us. And also to have data with sensors and cameras, we have the provision to install next month this measurement in a combined sewer overflow area. And there is also a new data and a new challenge for us. And thank you very much. Excuse me for the time. Thank you.
Not a problem. And thank you so much for highlighting such an important initiative. I don't know, Vanessa, do you want to try your audio again?
Now it's round the sun? Yes, okay. Okay, the Barcelona user case has two different approach. One is very practical in the field, that is what now Maria Jose just show us. And the other one is very theoretical, that is the analysis of data granular level. You have some number of the global N4 project just to implement what Linda said before, but go through my area of work. I work in the definition of data readiness levels. One of the issues that underline Linda is that citizen science, it's a good support because in-situ data could improve the lack of data, the need that we have nowadays for the urgent crisis. But there is a huge barrier behind the use of citizen science data, that is the robustness of this data and how truthful could be this data. So from the Enforce project, we was thinking about one question, how to get some tool that could guarantee the trustfulness of the citizen science data. And the answer was, okay, we could try with a model of maturity. Model of maturity like the technical readiness level, but in this case apply to the data. So a scale that will be able to define if our citizen science data are mature enough to solve some requirement related with the specific use. So we identify the what, and so we went through how to do this. And was very clear from the beginning, and for that now we are explaining to you, but also this is just the first step, because we are going to have dynamic workshop in which we would like your community involved in, because one of the first point that we underline is that these have to be multidisciplinary, and we need also a participatory system to define this tool. Because if you would like that this tool could be really implemented, we need the consensus-based approach to define all the scale of the maturity. Now we are, so we define the different phases, and also what we identify that was very useful for us and very important for the tools is try to implement in the real world. So use the user case that we have in the Enforce to test and see how it's work, the first that we build up. So here you have the timeline. Now we did a first survey. We're going to have a roundtable in the EXA 26. It's the European Conference on Citizen Science. But after that, as I said before, we are going to have open workshop for the community in which we are going through the criteria, because one of the huge work is the definition of the criteria of the scale. They are able to analyze not the quality of the data, because this is a huge point for us. The data quality is related with the data type. What we would like to analyze is the maturity of the data, so the complex in which, of course, the system of validation of your data, it's an important criteria, but we are not going through validate your data, but just to give you a scale with the different criteria, how your data could be useful. And after that, as I say, there will be a test in the field, in the user case, and so the consolidation with all the results that we get in all these steps, and a final participatory definition that maybe could be done also with the support of your community, and share the information to get the final feedback to define the nuance. As all the participatory system, of course, we are facing different kind of challenge. The most part are related to the multidisciplinarity approach, and the second one from the participatory. Because, of course, there are different methodology applied, there are different jargon, and also it's very important for us that all the stakeholders are balanced in the participation. For instance, sometimes it's happened that people from research, the academy, are overrepresented respect other group. In this case, we need also citizen scientists. We need also the legal expert, and also the maturity model expert. And very important by the operative point of view is to get at the end of the definition of this data reading level legitimacy of these tools, because we think that the consensus-based approach could be a way to get this legitimate for the end user. Should be scaled, flexible for the change that we have, because the scenario, the data scenario, the system are changing. So it should be able to describe different type of data and citizen science project, and also it should be sustainable. So in the long term should be applied. And what we get now is the first definition. It's just the yearly draft of what is the meaning of of data readiness levels for the environmental compliance. It's going to change because we have had a lot of feedback from the survey with quite 70 participants. But this is, for instance, an example of the collaboration with other community. While we started with a very clear definition, we analyze words by words, because by the legal point of view, for the legal experts, the taxonomy is a systematic system. It's very important. By the legal point of view, if something is not defining well and clearly, it doesn't exist. So you can work with something that doesn't exist by the legal point of view. So we started with the definition, and now we build up through the workshop, the criteria, and we go ahead also with the other point that we would like to share with the community. And that's it. I don't know, it was short enough, and there are some questions. I saw some question about Minka, but maybe there will be a discussion after. So.
Thank you very much. I will ask the audience to just note your questions down. We're going to reserve them for the open discussion at the end of the seminar. But for now, we're going to hear the last case study from the Enforce project before moving on to the next speaker. So Alicia, if whenever you're ready.
Yeah, thank you very much. Well, yes, to provide an overview of our specific case study of Valle Galeria, it is necessary to make a few preliminary remarks. Very quickly, firstly, the Enforce project aims to demonstrate how citizen science allows data collected by citizens to be integrated into environmental enforcement procedures in order to promote participatory and multi-level governance of local environmental issues. The case of Valle Galeria was chosen because the area located west of Rome is characterized by a particular phenomenon of pollution of various environmental matrices, mainly due to the former landfill of Malagrotta, which was active until 2013, was considered the largest in Europe and has been subject to various European infringement procedures. Today, the former landfill site is undergoing a structural safety work that has been launched, although several months behind schedule compared to the political promises, as usual. And this safety work includes biogas capture and leachate extraction, and they are both processes designed to resolve problems arising from the poor management of waste, which has caused significant pollution, air, soil, and water pollution, of course. In 2019, the Valle Galeria Libera Committee was set up with the aim of denouncing the situation at the former landfill site and, of course, for defend the local area. In addition to its website, the committee has also a reporting platform that can be used as a specific observatory for Valle Galeria. The platform is called Athena and can be used to report fires and miasma, so the odor pollution in the area. It is important to say that data and alerts submitted on Athena are forwarded directly to two municipalities, to ARPA, so the Regional Environmental Protection Agency, and in the event of fires to Civil Protection Agency. We are currently upgrading the platform's data validation system with the support of International Institute of Applied Systems Analysis and the European Association of Remote Sensing Companies in order to develop an application called GeoQuest, to be integrated into Athena. So this interoperability between the platform and the application will allow us to compare and overlay the data collected by citizens with the satellite data provided from GeoQuest. And this enables us to compare the two types of data and validate them when they coincide. This experiment has already been carried out, taking as an example the 17 fires mapped by the committee last summer in Valle Galeria and compared them with those detected by the satellite images using the VIR sensor. In this way, we were able to verify that the 17 fires reported by the committee coincided with those detected by the satellite. So, in other words, the development of the GeoQuest application aims to make civic data more valid and reliable in the eyes of competent authorities. In conclusion, we think that the data collected by citizens of Valle Galeria is potential evidence for environmental compliance, but as we know, on the condition that it reaches an adequate data readiness level that makes it admissible and reliable, and therefore, in this case, the enforcement is closely linked to the validation of civic data. And on the other hand, from a social point of view, the data collected by citizens can reduce the information gap and asymmetry between the community exposed to environmental risks and institutions. So, in conclusion, we hope that this 4 years project will enable us to witness the strengthening of citizens' ability to influence decision-making processes. So thank you very much for the attention.
Thank you so much all for sharing those use cases from the Enforce project and reminding us about the role of citizen science. We're going to move on to another example of a citizen science case study from another region. So Grace, whenever you're ready to share about the water quality data sharing network, please.
Okay. So thank you for this opportunity. My name is Grace Saunders Hogberg, and I'm going to be talking about a case study that is occurring in Canada. And the company or the organization is called DataStream, but I have to provide this disclaimer. I am not a representative of DataStream. All the information that I'll be sharing about DataStream in particular is on their website, and the slides actually has links to specific features on their website that I am going to be talking about. But I just became acquainted with DataStream through my background in freshwater resource management and through a contact that recently started working there. So just wanted to get that out of the way. So what is DataStream? DataStream is a registered Canadian charity funded through the Gordon Foundation. It's also a web-based open data scalable cloud platform that integrates and stores and standardizes and also displays water quality data. And by doing so, it supports collaborative water stewardship and improves decision making. And it's founded on these four key principles. I'm sure you're familiar with fair, care, and we have OCAP and trust. And I just wanted to highlight OCAP. This is a First Nations data governance principles that was developed in Canada by the First Nations, and it ensures Indigenous or First Nation control over their information, so to preserve their data sovereignty. So DataStream began in the Mackenzie River Basin, and this river basin is roughly the size of Spain, and it spans 3 provinces and includes the traditional territories of many of Canada's First Nations, Inuit, and Métis community. It's a region of vast wilderness, and it plays a major role in regulating Arctic climatic systems, and it's also significantly impacted by climate. Oops, I'm still on the wrong slide. It's significantly impacted by climate change, with melting permafrost affecting the ice roads, which are essential for transportation of supplies, and also impacting the traditional lifestyles of the Indigenous people that live there. So this area is also one of resource or interest in resource development. An example of this is the oil sands, which you may have heard of. Now, there are already many organizations that were monitoring water quality throughout this basin. However, their organizations had their own systems, the proverbial silos, which created a barrier to collating the data to generate reliable insights about the overall health of the basin. So the solution, eventually the Gordon Foundation, whose mandate includes supporting northern communities and addressing water challenges, partnered with the government of the Northwest Territories to build a solution. In 2006, the Mackenzie data stream was launched, and this is a platform where water quality data could be reliable because it could, oh, I don't know why my screen keeps, or my mouse keeps going ahead. Sorry about that. But it's a platform where water quality data could be reliable because it would be consistent and open, and as well as facilitate collaboration. So after the Mackenzie Hub was launched, monitoring groups across Canada who were facing similar challenges also partnered with DataStream to create regional hubs. So today there are 5 regional hubs representing the major ocean draining watersheds in Canada, and each hub has its own website to input data, but they all operate within one integrated platform. So collectively, the platform hosts over 60 million observations, 56,000 monitoring sites, and contributions from more than 345 monitoring groups. And you can see on this slide the various types of organizations contributing to the platform. But so the DataStream platform includes over 1,000 water quality parameters, but contributors are not expected to contribute to each of these, but to instead continue to sample and test the challenges that they are focused on or that they have specialist knowledge in, rather than trying to be a jack of all trades. So this is an overview of what I call the data value pipeline, or just the data value chain. And I'll briefly be touching on some of these in the next slide, but I just wanted to go to the right side where it talks about the data use. In terms of the user, it really is open to anyone because the data is fully open access if you just want to access it. But you only, on the website that is, but you only need to register if you're contributing data. So this is an extraction from their data governance policy. So I'll just start off with data standardization. So one of the biggest challenges that they solve is that of standardization. Instead of creating a new standard, DataStream chose an existing widely adopted one, and this strengthens their interoperability across regions and borders, primarily because of the shared semantics and processes for collecting and reporting data. So DataStream adopted the Water Quality Exchange schema, which is developed by the US EPA, and the WQX was specifically developed for sampling-based measurements and is one of the most widely used water quality data models in North America. So contributors can upload their information into Excel templates, and then the platform converts this into machine-readable formats and flags missing or inconsistent entries. So in terms of metadata management, on the metadata side, the DataStream requires comprehensive documentation aligned with ISO standards. And some of the fields that are mandatory, some fields are mandatory, but some are also optional. And in terms of licensing, there is a required field, and they offer 3 options for contributors, whether they want to choose attribution license, public domain, dedication and license, or a government license, which would be for governments that have a pre-existing open data license. And for convenience, they also have a metadata worksheet for contributors to use as a guide prior to inputting their data into the form for upload. And in terms of integrations, DataStream is integrated with data catalogs and indexing systems to improve discoverability. these integrations enable them to import data from other open data systems using the same other open data systems that are using the WQX model as well. And this includes government portals. In terms of discoverability, DataStream is discoverable on many different platforms, including the Google Dataset search. And its API allows other platforms to pull data directly for research, machine learning, analysis, and reporting. And one example of this integration, of their integrations, is with the Great Lakes Observing System and their platform Seagull. So Seagull focuses on real-time data from buoys and weather stations in the Great Lakes, whereas while the Great Lakes Data Stream focuses on field and lab-based sampling across watersheds that feed into the lakes. And so these systems are able to be complementary and provide a fuller picture of the health of that watershed. So in terms of preservation and contingency plans, I kind of mashed those two together, even though they are important issues. DataStream leverages the AWS cloud infrastructure for scalability and for backup and recovery. And their repository has cross-region replication enabled, where 6 copies of the data exist within the system at any time. And this supports them in disaster recovery situations and ensures continuity. And very briefly, the contingency plan, in the event that they have to be decommissioned, they have a process where they have a policy where they will do a search to find a suitable repository to migrate the data to, and they would also included in their policy is ensuring that the metadata and documentation is updated and then also updating their stakeholders. So I just wanted to share one of their case studies that they have posted. And this is the name of the actual article is the water safe to drink? Are the fish safe to eat? And in the bottom is the same title in Inuktitut. And this is in the region of Nunavut, in the Kivalik region. There are many residents who continue to gather drinking water and fish from the rivers that have been used for generations, and this makes freshwater health central to Inuit lifestyle and their food security. When a new mine was being proposed near Baker Lake, the community members asked this actual question: is the water safe to drink? Are the fish safe to eat? And clear answers were not available at the time. And so the Kivalik Inuit Association launched a monitoring program combining Inuit knowledge and scientific testing. And the elders were able to identify key sites and shared observed changes. And then scientists tested for nutrients and metals. And the results showed that the water was safe, but nutrient runoff from upstream mining led the company to improve their water management. And this demonstrated how Inuit knowledge and community-led science can influence industry practices. And so that's all I have to present for you today. Thank you for your time and for your attention.
Thank you so much, Grace, for reminding us about the role of Indigenous communities and sharing those principles. Certainly I knew of CARE, but it's good to see that Canada has additional ones. All right, we're going to move on to the next presentation, and we'll hear from the Copernicus In-situ section about strategic collaboration with data providers. So Franca, if you're
I'm here.
ready, you
Sharing
can
the
share.
screen. Thank you for this opportunity to contribute to this session. I'm Franca Di Sabato. I work for Links and Ithaca. And today I'm here on behalf of the Environment and the European Environment Agency. And I'm happy to present the activities performed by EA within the Copernicus In-situ component. And we also put a particular focus on its effort to enhance the collaboration with the Copernicus In-situ data providers. What is the Copernicus In-situ component? Is made of different actors that works within the services and also in the space component. And what they need is the in-situ data that include ground-based air and seaborne data derived from sensors, and then also geospatial and ancillary data that are licensed and provided for the use by Copernicus. The data are used and managed by trusted entities and every day, and EA steps in when a coordinated and programmatic approach is needed. So we all work together for the use of in-situ data within Copernicus. The areas of work for EA are mainly four. The first one is the state of play, in which EA is responsible for the maintenance and the update of the state of play of Copernicus in-situ data. That is offering an overview of in-situ data requirements, challenges, and gaps for the entrusted entities, and is also providing a comprehensive view of in-situ data providers. The second area, instead, is focusing on ensuring data access for Copernicus. So EA is working to facilitate the collection, compilation, the sharing of in-situ data so that they can be readily available for operational use. The third area is of advice and support, so takes a role of guidance for the in-situ data and organizes a forum in which all important stakeholders can speak about in-situ data related topics, find a solution, discuss issues, and find a solution in a cross-cutting and holistic manner. The fourth area in which is working is engaging with data providers. For this, EA engages with the data provider to improve the access and the use condition of in-situ data, of course, in accordance of the needs of the Copernicus services. I'm just reporting some information that can be of interest for this session. And so I wanted to speak about the access to geospatial data because EA operates and maintains the Copernicus Reference Access Portal that is called CORDA. That is a single entry point through which all selected national and regional reference dataset are provided to Copernicus. The users of this system are mainly mapping services. The data is not hosted by EA, but is hosted by the regional and national authorities that provide the data. The CORDA provides also details on the quality and access condition of the dataset, and also supplies links to the data provider. And furthermore, has a built-in mechanism that is making sure that all the links and web services are up to date and functional. Besides this function, CORDA is also providing semantically harmonized multi-country database for key selected topics that are land use, buildings, and hydrography mainly, and is available for authorized users within the Copernicus service and data providers. Just to give you some numbers, we have more than 2,000 datasets of more than 300 data providers for more than 40 countries. Very important is the community of stakeholder for the in-situ data. We have European organization and networks, international organization and networks, but also private networks, research infrastructure, academic institutions, and private companies. They also make their part in the provision of the in-situ data. Very important for getting access to the data are the partnership, the cooperation and license agreement that are done with the data providers and the networks or data providers. Two main efforts were made for Eurogeographics with Eurogeographics and EOMET with Eurogeographics. There was an agreement in 2017 from which Copernicus gathered a bit new data sets or the update of the data set for more than 150 cases for more than 18 mapping agencies. While the agreement with Emernet that was done in 2017 as well, I think, and is also allowed the access for more measurement, meteorological, climatological, and hydrological data that are used within the different Copernicus services that are emergency, atmosphere, climate change. And on the top of this, there are also individual agreements that were done in order to support the different services. Also very important are the collaboration outside Europe, as Copernicus is a European program, but has a global coverage. In the last year, we engaged new countries that include Japan, Canada, Australia, Chile, Brazil, and Philippines. A very important mean for EA to take on board data providers and convince them to share the importance of sharing the data is the use cases. So EA built a database of use cases. There are several, and they have the aim for each of Copernicus services to show how the data are used. As you can see, we have several both for the topographic maps that are provided by In-situ data that are more geospatial, and also for the observations on the measurement, hydrological, and so on. And also good distribution among the services. Just the last two examples, I will be very quick on this, but we wanted to show a couple of use cases. The first one is for the Copernicus Emergency Service. And in regards an activation, the civil protection that during a flood in Sweden asked for the monitoring of the state of the flood, and thanks to the national Sweden 1 meter digital terrain model, it was guaranteed a better accuracy in defining the water depth. The other application was instead for the land component of the Copernicus services, and in this case, the use of national authoritative hydrography at the scale of 1,000 to 1 to 5,000 for Spain. Was very important because this data were used for the manual correction of an hydrological condition in them that was generated within the new suite of the EU Hydro product. This kind of correction allows that the flow path and river lines generated within this suite align closely with the real condition, the real world condition. Therefore, the higher resolution of this dataset and the authoritative dataset enable an improved result in the test area in the southeast of Spain. Of course, just give you some information. Thank you.
Thank you so much. Certainly, coordination is one of the critical elements identified in the In-situ data strategy. So you're giving us a lot to think about. I do have a question about challenges, but I'll reserve it for the open discussion for now. We're going to move on to the next talk, which is about in-situ data needs in support of satellite calibration and validation. So Thierry, if you're ready.
So thank you for having me in this dialogue. Very interesting until now. Now I'm showing more a user case, using in-situ data, and indeed for the support of satellite calibration and validation, what we call CalVal, and I'm the project scientist for CalVal at EUMETSAT. So trying to coordinate all the needs for the satellite mission cooperated at EUMETSAT. So this is the fleet, just to give you an overview. And we have the three main categories with the geostationary, which are mostly centered over the 0, latitude and longitude, so over Africa. And we have a couple of Indian Ocean. And we have the polar orbiting that is completing the geostationary one with the EUMETSAT Polar System. And what we call optional and third-party program, but they are not optional anymore and minor anymore, is the Copernicus program, which is a big part of the satellite. It operated on behalf of the European Commission at EUMETSAT. And all these missions are operational. So what it means operational from EUMETSAT point of view, because it's also important for what kind of validation data we need. So we have data dissemination to our user, 99% of the data in 24 hours, 7 days a week, with an NRT, so a timeliness of a couple of hours for the LEO orbiting, and up to 20 minutes or below 10 minutes for the new generation of the GEO satellite. So from the sensing time to the user, 10 minutes. It's a very challenging dissemination. And then, of course, data continuity between all the satellites you saw. We have to be sure that there's a consistency between the program and also between the system. And of course, the data quality with the calibration and validation, which I will go more in detail now. And all this is what I call the temple of EUMETSAT operational mission and product. And all are dependent. You cannot have dissemination quality or continuity independently. So this is the result of such retrieval of satellite data. As you can see here, it was one of the first acquisition of the FCI, of the new generation of the EUMETSAT geostationary system. And it was acquired in June 23. And you can see at that time here the Canadian fire, the smoke coming over Europe. And it's one challenge is, for example, to distinguish cloud from aerosol and so on. So we have to rely, satellite provide global coverage, which is a key advantage of satellite observation, remote sensing observation, but we need ground-based data to validate, to give us the real number on very crucial point. This is how we would like to have it, but however, this is the reality. So we have how to say, the reality highlight the gaps, especially over ocean, where we have almost nothing in terms of ground-based remote sensing. And this is very crucial, like for aerosol, we just give the example, because we have different retrieval over ocean and over land. So we need to also have some data to validate the aerosol product, for example, in this case, over ocean. So a bit of background, context of the satellite CalVal. Satellite CalVal often relies on existing already ground-based systems, the so-called in-situ data, which we are talking about. For example, from WRO system, the WIS 2.0. But all these data sets are not fulfilling the needs of satellite mission, especially the new one. So what we ideally want is what we call the fiduciary reference measurements, FRMs, which I will come quite often as acronym in my presentation, to suite for satellite CalVal. And FRM are tailored and fully characterized measurement, SI traceable, or also we accept, especially for remote sensing of the atmosphere, community recognized best practices. That means networks that have a very consistent retrieval and centralized retrieval that can provide their own standard and reference. So the FRM in support to operational mission, of course, it's related to data dissemination, continuity, and quality. And so it means we need fast data access. So timeliness is very important with easy, of course, data access, but today it's getting less and less an issue, and human readable formats, I would say. We are using HCDF, but of course, it has to be self-explanatory. Of course, we're aiming for gapless data product, temporal and spatial. I just show the spatial gap that we have. With the long-term availability, because we do the root processing for climate data record. Now we have we have the 40th anniversary, so we have 40 years of data now. We can do a very nice trend. And the accuracy of the ground-based product should be comparable to the satellite mission accuracy or better. And also, as we don't have, we have for GEO is easier, but for the LEO orbiting is possibly also measured when the satellite is passing over the ground-based measurement. To give an example here, the Copernicus mission, which is an ocean mission, so a bit ocean background is always good. Just to show you also, because we have a slight different understanding in our community between in situ and what we call remote sensing measurements for the ground base. So the example typical, because it's an ocean mission, so we rely on the ocean color and the sea surface temperature. We rely on buoys, so we have plenty of them around the globe, and these are very easily traceable to SI and what they call in situ, because the measurement is directly from the media, from the water. But there's, for satellite retrieval, there's this nasty thing between the ocean and the satellite, which is called the atmosphere. And we have, for the ocean, for the surface, any kind of surface, we have to remove the atmosphere from our calculation. So we have to take care about aerosol, surface contribution, cloud, gas absorption. And this has to be removed to be able to provide you the sea surface temperature and ocean color. So we have to do FRM, also for atmospheric column. And this is relying on this kind of remote sensing of the atmosphere, this instrument. And the challenge is to put them on ship. They have been constructed for land, and we have now a new couple of programs, not only EUMETSAT, but and also at NOAA and ESA and JAXA and GMA, so we're also doing some experiments to put them on ship. And here, possibility is getting more difficult, and that's we rely here on committee also recognized best practices. Here's some example what we are supporting. As I said, is a challenging exercise as instrument developed for land. And we have, it's not campaign, they are commercial ships that are doing regular routes, so acquiring regular data. And we have two candidates actually from IPMA, from Portugal, and one has been recently also installed on the Hurtigen cruise ship with the help of NIVA and NILU in Norway. And we're seeking for other candidates, so feel free to contact me if you have some other regular ship that would like to have instrument. So some take-home messages. So as I said, the calibration and validation activities are the key component, as you saw from the Earth observation mission, especially from the operational mission, with three major objectives, which is to provide data product with all the documentation and traceability, which are linked to our user requirement and CalVal plans. Also to gain understanding of the sensor performance and the algorithm characterization to improve their quality and reliability, to perform the FRM gap analysis, as I just showed, with a continuous exercise to identify where we could help to support invest to FRM, that's the ship remote sensing and campaigns. And what we already highlighted, especially I put in bracket ground-based remote sensing, not only in situ in our language, is also the covering ocean and high latitude region. And I would like also add Africa for importance for the EUMETSAT geostationary mission. And providing multi-species information, that means also including the surface contribution. I like, for example, the presentation from Malaysia, which showed the field campaign or the measurement in Rome, because we have also their big super site in remote sensing, the Bakwini site. So it's a nice combination there to have everything on one side. This to improve the atmospheric composition knowledge, to measure it, but also to remove it to do surface measurement. And also, ideally, with the central processing, that's ensuring the standardization, the calibration, and the verification of the data, so the quality control. And I think with that, it's done for my presentation. If you have more questions or information needed, you just go to this link, and there are much more FRM study we are doing any kind of measurement. Thank you.
Thank you so much, Thierry, for sharing those perspectives. Certainly, we'll share these presentations via the GEO Knowledge Hub, so people will engage. We're going to move on to the next talk, tying it all together, interoperability and standards. So, Piotr?
So yeah, also thanks for having me here and inviting for this dialogue. So I will share some of the thoughts we are circling around recently, but also in the end there will be some questions to you all on the to maybe have this dialogue also going through. So there are obviously obvious things like simply the all of this stuff about the data, and you've seen a lot of these cases already here. A lot of the other which are not mentioned here, which is maybe changing, and from my perspective, is that there's more and more of this data coming also from the processing and all of these digital twins which are popping up here and there and trying to estimate the what if cases and other Gen AI things which are generating synthetic data. And all of that is based on the foundation. So still the foundation quality matters for all of that which is produced as the derivative. And yeah, I have noticed that there was also both the machine readability and human readability mentioned. For a couple of years, we've been talking about the machine-to-machine integrations and interoperability that is machine interpretable or AI ready, but nowadays there is also voices that we should care about the human readability as we are increasingly complicated. We are implementing increasingly complicated scenarios. So just a heads up on the standards, just an overview for those who doesn't, let's say, know what the ecosystem which OGC is supporting. A lot of the standards are based on years of practice, and they are probably well known. Some of the others are less known, but they are covering in principle all of these value chain steps, including the recent ones, including these aspects of the agentic integrations and this whole discussion about the MCP, which is just quite new. We don't know if there is a geo flavor in that which is relevant, but for sure all of this are benefiting from the services which are developed through years and the APIs. And this ecosystem is naturally evolving. So we see the storage, a lot of the data which is stored in SCDF. Some of the infrastructures are moving to the new formats, which are, let's say, inheriting all of the knowledge and the conventions from the previous ones. But sometimes there is a need to align. And then coming back from the user, which is simply benefiting from all of these optimizations like tiles and services, we have more and more control of their acquisition process, and that's one of the aim of the connected systems, which I will say what in the next slide. But this is about the control of the actuators, which are either doing changes to the systems or doing changes to the acquisition systems. And naturally, worth to mention that that initiative after the GREX, and now it's fully fledged OGC working group on the geospatial observation needs and requirements, which is supposed to help also in this process to connect the users to the data providers and vice versa. What is quite useful is that all of the standards are somehow connected to each other, and nowadays we see more and more of this combined standards. The connected system is one of them, which has reviewed the sensor ML description, which has reviewed the description of the acquisition system and the observation models, but also onboarded some of the other standards. If we care about the about the UAV's velocity over the field or the angle, all of these things that we know from the Earth observation already. Just here we have more flexibility in the control and also, let's say, more fidelity in the data. What is important if we combine this is that there is this mix of the technical protocols. We all benefit from the software support and the platform support for the technical protocols, but we also care about the knowledge technologies. And as was said, AI readability or human intelligence readability is something that is embedded in this standards. The context is naturally important. So paraphrasing, all that you need is focus. The focus on the context is really important. It's not only about bringing up several layers of the data, but also having the awareness of when and where what time is the things are happening. And the generalization is like open question actually for us, how far we should go with the standardization of the actual rules between the word replication models and word systems that we could derive from the data, and knowledge we can get from the data, which is usually when we talk about the in-situ data, it's quite fragmented, but also the demonstrators, digital twins based on this data are have the challenges of the portability and really generalization of the rules, and naturally the relationship with the higher level policies and the indicators. What I said is here reflected once again. It's the foundation. We have applied this model in a couple of projects recently, which is actually proving that all these standards, which are at technical level, as if well implemented, are inheriting this core nucleus of the semantics of our word description. But then, if you go into different flavors of that, about all of the cases that we have here and all of the others, we naturally have these flavors which are either domain specific or case specific or the infrastructure specific. And then you need to combine it when you want to provide this interoperability on the domain level. So there is a horizontal and vertical, which is meeting here in this core domain information model. But we have also seen that there is a proven mechanism of the extension. So what we see in the rest of the web services, what we see in the netcdf files, which was mentioned here, all of these features types inspire schemes, and recently naturally Stack, which is simply growing based on the very lean core, and all of these extensions which are coming from the community are very helpful. Just we need to care about the governance of these profiles, and we need to take care of these links that doesn't spread too much, and there's no too much overlap and conflicts in this information. What is the practice is that simply we are building this kind of templates also. So OGC has invested already in the modular specification concept that now the standards are published in parts, which you can implement or not. Which naturally increases the entropy of the description of the systems. But to facilitate the adoption, we are also investing in this templates of the model. So citizen science was discussed in the beginning. We have also done this citizen science pilot for the Iliad ocean information model, where you actually have your profile, your template in OGC API features like GeoJSON extension. But then all of these properties are mapped to the ontologies, and therefore you don't need to care about that. So whoever is actually implementing doesn't need to take care of these links because they are provided ad hoc, and then everybody who is contributing to the data can have the validator that the data is still at least on the what could be automated on this level can be based on this templates and the validator frameworks. And the maturity model was mentioned already. There are naturally the standards compliance maturity models or semantic maturity models, which are somehow compliant with the DMP from GEO and some of the others frameworks. Just not to remember that there are these measures. And as promised, the questions. So I understood this is a dialogue also session. So what I'd like to maybe hear from you here or later is like, what should we as the standardization community and the geospatial community focus on? Is it like good practices of the standards applications, of these extensions or whatever? Supporting the data formats, supporting the in the maybe new data formats with the semantics, or maybe simply new data formats and the cases which where we have the rich metadata, which is coming like video streams, images from all of these semi or fully autonomous systems. Should we care about the indicators, really about the links between the indicators and their definitions, or should we care maybe about the governance of this whole systems? Maybe extending the idea of the GX or any others that is happening in this in the working group. But I wonder how does the EA and GEO community thinks about that, and that is probably the questions from my side.
Thank you very much. And thank you for preparing these questions. I might ask you to share the slide again when we get to the dialogue part of the conversation. But for now, we're going to move on to the last presentation. So Marie-Françoise will step in for Helen and present the GEO In-situ data strategy.
Well, thank you, Leo, and thank you all. So I will introduce the GEO In-situ data strategy, stepping in for Ellen Glaves, who couldn't attend, and letting Leo focus on the moderation, but because he's a co-author of this presentation. Up. So the in-situ data brings specific value to the Earth observation. I think I am missing one slide here. Okay. It's here. So the in-situ data brings specific value to the Earth observation data sets in general that are reminded in the strategy document and highlighted in the slides. The in-situ data is different to satellite-based observations in that it usually records information about a very specific area and often at a fixed location, even if it is not the case, for instance, for the sensors such as the drifting buoys that were mentioned by before by Thierry. But as any type of EO data, it has strengths and weaknesses or challenges, let's say, that are that it results in a highly heterogeneous data landscape, and that includes some significant gaps, as well as having a plethora of different formats and standards. And this has been mentioned also by Thierry for the gaps and by the different formats and standards by Piotr, all of which present a challenge for providers and users of in-situ data. For example, compiling a global dataset of ground temperature involves a huge amount of eventually fragmented data providers that are utilizing various sensors to generate the data and at potentially different temporal frequencies and in inconsistent units of measurements, which makes platforms such as Copernicus In-situ so critical. So the significant value of in-situ data is demonstrated through various applications, including the GEO work program activities. And it has been mentioned also before, like the calibration and validation. And it provides also data and measurements at places which are not accessible by space, like under the clouds and so on. And it often measures significant variables in the Earth system directly impacted by human activities, as a temporal and spatial distribution resolution that allows more accurate and frequent measurement. We can see that also with the citizen science. It provides longer time series that include historical measurement that are so critical for long series to calibrate climate change impacts. And it's the only legally admissible form of EO data in some situations within the member states. It's essential for realizing GEO mission, but not only, a lot also of businesses and supporting UN SDGs. So we mentioned the diversity of the in-situ data, and the challenge it can be to consolidate the different data sets to fulfill the needs of users, to respond to new and emerging technologies such as artificial intelligence, but not only, and machine learning. And to maximize integration and reuse of in-situ data requires existing and new observing networks to implement common data framework, and wider implementation of common data management practices such as fair, care, trust, and the GEO data sharing and data management principles that have been mentioned by Grace before. And we could see that these principles have been very critical for successful projects such as the one from Grace. So the in-situ strategy, the overarching goals are that we want to develop an increased coordination of in-situ data providers and to mobilize the GEO members and participating organizations, engage with in-situ data users, and advocate for in-situ open data and knowledge. This strategy has been validated already, and we just wait for the next GEO plenary to endorse it officially and publish it as a public document. And we want to foster a change in the mindset of the global GEO community, and more widely, it's not only for the GEO community. Some people work on Earth observation and are not involved directly with GEO, and all the work we do can be useful to all. By ensuring in-situ data sharing and management is an integral part of all relevant research activities. And we want to support this approach by delivering the tools, policies, and practices needed to maximize the in-situ data sharing and integration. So the objective we have in GEO is to identify and monitor the requirements of data users for discovering, accessing, and reusing in-situ data. Thank you to Thierry, who has expressed the requirements EUMETSAT has. Determine the barriers to making in-situ data that respect the relevant data management principles, like fair, care, etc., openly accessible to reuse. And I think that Piotr is interested in discussing that too. And what we want to do is to coordinate within the existing national and regional in-situ data networks across different geographical areas by domain, with the aim of defining and describing the existing in-situ data landscape. We need to know where we are and where we want to go, promoting sustainability and improvements to observing networks, and identifying gaps in current in-situ observing systems. And the gaps will come not from what the data providers can bring, but from what the users need. And this was expressed also before. And supporting implementation of a GEO infrastructure that can serve as a gateway for in-situ data, stimulate the adoption of appropriate tools for data management, and integrate new data sources such as the citizen science, for instance, but not only. And of course, we want to advocate and monitor the implementation of the relevant data management practices and principles as they apply to in-situ at the national and regional scale, with the goal of taking a leading role in promoting good data stewardship with the data management principles. And this is, we have done that in previous webinars and dialogues, but of course it's an endless activity. Encouraging the use of flexible and common data licenses. We have identified that the legal law and policy aspects in the data provisioning and data use was a weakness, and we try to push and support that. Illustrating the use of in-situ data for increasing environmental knowledge and minimizing and avoiding loss of in-situ data, including through adoption of relevant archiving and preservation best practices. Because we know that a lot of in-situ data is measured in research projects, and we think that it's nice to have some projects like I don't know if Enforce has work on the sustainability. I guess they do because it's requested by the European Commission. But in case at some point some data is at risk to be lost, GEO can have a role here. So we have defined a strategy, but to have a successful implementation of this GEO data strategy, we need a comprehensive and coherent set of actions to be undertaken by the GEO community. And again, even more, even if you are not part of the GEO community, you can be interested by this implementation document and align with good practices. We have to raise awareness. It's one of the goals of this type of webinars. Support the adoption and implementation of relevant best practices and standards, and provide the infrastructures and tools necessary to ensure availability and reuse of in-situ data. We need a strong commitment at national, regional, and global level to ensure the availability of resources that are necessary to support in-situ data system and the associated stewardship of data and knowledge. It's not one person or even a group of persons that can push that. It has to be adopted and validated, and this is also why we make so much outreach. Implementing the in-situ data strategy involves key actors from the national members, the work program activities from GEO, but also the participating organizations and associates that can be private company, regional and national GEOs, and the GEO Data Knowledge Working Group, to which with whom we are working with, Leo, Bent, and I, and Kalamkas, and so on, and the GEO Secretariat. Kalamkas is part of the GEO Secretariat. And the successful implementation of the in-situ data strategy requires these different stakeholders to define role and responsibilities. So in summary, we have defined a GEO data strategy that provides a framework for open sharing and ground-based observation for our Earth system. And the approach aimed at overcoming the specific challenges associated with the acquisition, reuse, and long-term availability of in-situ data, as well as supporting the sustainability of associating observing networks. So as said, this in-situ data landscape is very fragmented, and sometimes that's in space and also in technologies and so on, but also in time we can have projects that disappears and new projects that raise up. And we want to leverage GEO unique convening power to coordinate the community and foster the adoption of the approaches and practices necessary to maximize the access and reuse of in-situ data. And this is why we need to engage with you all, because we need you to bring your needs, your expertise. It was done partly with this webinar. Your needs, it was also expressed by Thierry and so on, so that we can adapt our implementation document to serve the expectations of the EO community.
Thank you so much, Marie-Françoise. Certainly all the presentations are relevant to the implementation plan of the strategy. And thank you all to all the speakers as well. You've heard from the speakers, but now we want to hear from you. So we are going to open the dialogue part of this webinar. Maybe I can kick it off with a question related to the Copernicus in-situ data providers. So, Franca, I'd like to know, what are the main challenges encountered with in-situ data within the Copernicus in-situ component?
Yeah, thank you for the question. I think Marie-Françoise gave a good overview of main challenges, and yeah, so I can just briefly say them again. So the problem of fragmentation in time, in space, and then also the uncertainty of what is available now, if it will be available later. And then that maybe also the purpose of the data that are shared, maybe they're not taught for certain application, so there can be some interoperability problem or inconsistency also in the content. Okay, something that didn't come up from Marie-François, but I understand why, because we had this problem in the emergency field, is the timing to access the information. So that is need to be quickly available. And Copernicus Emergency Service need to be organized for getting a rapid access to the in-situ data for the production of the different maps and products. And also the problem of historical time series that are not always complete, and licensing problems. So the access to the data, if the condition of use and reuse are clearly stated, not always this is the case. Yeah, I think more or less we gave an overview. I don't want to take too much time on this. Please tell me if you want me to speak more about something.
Thank you so much for that. Yeah, I was just interested in the challenges in the context of the in-situ data strategy implementation. But certainly, so I'll turn it over to the audience. Do you have any questions for any of the speakers? Bente.
Yeah, I can start, but I really want the others in the audience to join me after my question now, because I had a short chat here with Thierry concerning the access to in-situ data and for CalVal. And we had this discussion. We were in a meeting at UMETSAT the other week, and we were discussing, can we use in-situ data for like from the national? There's a lot of national networks of in-situ data, and they are not necessarily well fitted for CalVal. But on the other hand, they can also, the combination of CalVal in-situ data and the other types of data can enhance the information that we have. So I asked Thierry, what does it take? Because I know just from Norway, which is one of the gap areas, that we have so much data, in-situ data, and how can we? Are there any quick advice you can give to us, Thierry, on how the nations can support this in one way?
In Norway, I gave you an answer in the chat. There is at NILU, they have the Nadia database, which is we are using, and is one contact I can provide to you. But in general, it's a case by case. I mean, we as data user, we prefer. That's the reason I insisted on the centralized data access. Is I don't like to use the word network, but what the Copernicus is doing with EA and so on. This is kind of very helpful for us space agency to have one overview of all the data access. This is one thing I could recommend really to have on this. We cannot go to each city, Air Paris or Rome to ask, can we access your data? It should be at least, also regional, as you point on that. I mean, if I say Europe is regional, we could find some solution on that level already that we have some, and Copernicus is doing that for us. So, and the second is on future project, because we also had the discussion 2 weeks ago in EA, when it was in Copenhagen, is that there are a lot of data existing, but we call the homeless data because they are not in the right format and so on. And I can understand, because sometimes it's projects that have been done by some research infrastructure university, and they don't have the work power to do this work. So this, for future project, I mean, European Commission and so on can add requirement on data formatting and access. So there's already a first step to avoid this loss of data. And second, some infrastructure, I mentioned actuaries for the atmosphere, are offering already to format and provide visibility to this homeless data. So there are many points we can work on. Hope it helps.
Yes, absolutely.
Just a question, Thierry. Is the offer of actuaries for global for all the world?
I think at the moment they concentrate in Europe. We have this actress, the project is called Cargo Act, where they also want to offer this for non-European network. They started actually with the NDAC, with the LiDAR data from the US, and yeah, it's a bit on standby at the moment. But they are looking for this kind of possibility to format and access or provide visibility to our data. Yes.
Thanks.
All right. Thank you. Dominique?
Yes, hello everyone. Just to follow up on this, so I'm very glad that you mentioned Actris, but Actris is just one of the research infrastructure organized in Europe. There is many others. You mentioned your own presentation, NIVA and their ferry box, which are part of another one, which is called Jericho. And basically this research infrastructure as platforms are deployment broadly and are ready and possibly are not providing the data that is needed for a specific application now, but there is a potential for a huge deployment of a specific measurements if needed at any time, and with a coverage at space and time that could actually fit any of the purpose of CalVal, for example, but other. So in Europe, at least, so building on the existing research infrastructure, I think is something that we should pursue.
Yes, I had only 7 minutes, so I had to do a choice. Yes, but totally agree with you, Dominique.
All right. Thank you. Vanessa?
Yes. Could you hear me? Because I'm back with my headphone. Yes, no? Just to add one point, because nowadays there is a new European project that is VX concept project that is very interesting because now they are working in try to define citizen science data infrastructure. So recognize the citizen science data as research in the framework of research infrastructure. So it will be support what now you say to use, I don't know, LifeWatch, Jericho, and so on. There are a lot of kind of different infrastructure that could support. And also, for instance, in our side, we were working in a very interesting project that was Minke. Minke project was a project around ocean data together with meteorologists. And we will try also to put in citizen science data from marine litter or the fine. So there are a lot of work ongoing now also to include citizen science data also in the discussion of the research infrastructure that maybe we should take into account to include in-situ data and also the local description of the data. Just was one point about this.
All right. Thank you for that remark. I see a question in the chat from Teresia, and I'll invite any of my colleagues in the GEO Data and Knowledge Working Group to respond. She says, how can or will GEO balance global standardization with the realities of diverse locally collected in situ and citizen science data? And she says, knows this is a bit ahead, but is this foreseen in how the ISDS will move to implementation? Marie-Françoise?
Yes, so good question. And this is something we regularly said in OGC I work with before. If you want to go fast, go alone. If you want to go far, go together. So you can have a local project where you want to go fast and your users will only be local. So maybe you don't care about standardization. If you want your data to be reused, to be more persistent, to be reused by others, if you want your project to have a more global impact and so on, then you need to go to standards. It's completely normal that you have some proprietary solutions that are more advanced, that are very high in progress and so on, because you need some pioneers. And then standardization follows, and what standardization brings is that it can involve more stakeholders, and it can enable you to reuse open software, to reuse not only data, but also solutions that have been developed by others. So in fact, you will always have some proprietary, local, non-standard solution going fast and very clear, and standards and so on. We have seen the presentation from Piotr explaining that our standards development and governance tries to serve the community, integrating all the very high speed of the new data developments, new technologies like AIs, new requirements or issues like trust and whatever. But of course, you will have two different speeds, and it will depend on what you want to do, I think.
Thank you. Bente?
Yeah, very short. So Piotr, he was mentioning the Iliad project, which was building digital twins of the ocean, and citizen science was one important component there. And the second part of Teresia's questions there, what kind of governance mechanism will be prioritized to improve trust, quality assurance, and equitable access? One thing is the ocean information model that I believe Piotr mentioned, to take into account the thematic, very specific parameters and make that into one information model. But what we learned, for instance, from a project, from a twin on jellyfish, which was based entirely on citizen science data, but it was governed by a University of Haifa in this case. So it was a university who was using their expertise to qualify, to quality check the data collected by the citizens. So there was this system put in place. In this case, it was a jellyfish, it was an operational service, etc., but it was governed in this way with experts to be able to trust the data and have a quality assurance. And it was integrated with standards and an information model. So I will recommend, I can post a link to it in the chat as a good example of how it can be governed. Thank you.
Thank you very much. Are there any additional questions? I'm just going to look through the chat, but feel free to raise hands. So Marie-Françoise asked, is the FRMs defined somewhere? Not what it is, but the in-situ that is.
It was a question, an answer to Peter Strobel, but I messed up a little bit the chat.
Oh, all right.
Give me a minute, I'm answering to Peter. Basically, I can answer here. The FRM are a subset from in-situ data. They are not, it's how you have to understand that. And I can further add that there are also FRM quality assessment paper at CEO's level, but also at WMO, because asking the perfect FRM, you get nothing. So we have to be pragmatic and to have, I mean, there's a limit where data are not FRM at all, for sure, but some data are just missing timeliness or are not fully documented. And we have to support this data to become FRM. So they are, I can send link, I don't have it on the shelf, but they are, there's a paper published by CEOs describing exactly that.
And Thierry, do you have the concept like in Copernicus of optimal FRM, acceptable FRM?
Yes.
And yes, okay,
yes.
Great.
Yes, is the CEO's paper, and WMO has also what we call the tiered approach. It's basically the same. Okay. This was developed for the greenhouse gas, because you have, for the greenhouse gas is a good example where you have no good station that can provide the accuracy needed for supporting, for example, CO2M, which will be launched in 1 year, or other greenhouse gas mission. We are much more demanding than what we can provide, and here we have to this tiered approach or this classification of FRM was discussed at WM.
Please send us the links or references, papers, or the links of this work. I think it would be useful for our working group.
Yes.
Thank you.
Thank you. Kalamkas, I saw your hand up.
Yes,
Aika.
I thank you all for all speakers. It was very interesting. I actually learned a lot. And my question probably not related to the specific of all the topics, but general to everyone. So I would like to know if there is any, collaboration with universities to incorporate subjects related to standards like data standards, infrastructure standards, and not just, the standards, but also the problems that we have with all this data and infrastructures, and what are the consequences of this, or to kind of have them incorporated in the curriculum. Because I ask this because many students often have to learn this knowledge along the way, so through the attending webinars like this, or like attending some workshops, so not in the curriculum at the university. So what are the practices in place if to deliver this knowledge to the youth? So thank you so much.
Thank you so much for that question. I don't know, does anyone have insights?
Well, yes, I think that it's very challenging, Kalamkas, in the same way that the consortiums have been created because the ISO and WMO and so on were a bit slow to define standards that had to be stable for many, many years. The consortiums like OGC, but also ITU and W3C have been created with volunteers to speed up the development of that. And then the big standardization bodies endorse or not the standards that come from there. And we have seen in previous European projects with Bente, for instance, that the universities have hard time to adapt the curriculum to the speed of the technology. And so this is why I think a big amount of knowledge goes through these webinars. It's also because it's in between knowledge and research. We are progressing together. And so I think it's a real challenge for the universities to be able to consolidate everything that is happening into stable courses. And so there are more and more online support and online courses, online resources. Many European projects have worked on that. Well, it will come back to me. There are some, and I will put some names in the chat later. But I think for universities it's really hard.
Thank you. Yes, I understand this.
Yeah, thank you. I think I'll take Piotr's hand first because it might be related to this point, then Washington.
Yeah, just to comment on that, and I put the link to one of these initiatives, which was built for the for interoperability awareness, specifically for people who are not that familiar, not coming from the even geospatial, domains, willing to provide the services. And yes, they can. That was also in the comments that they can come across some of the issues that simply are required on the later stages of the integration or data provision, service provision. And I would just repeat what I put also in the comment that it may be less if you want to take it practical. It may be more important to simply have these principles in mind, like what kind of information is needed, which needs to be preserved, than implementing the with particular standard in the particular format, because that can be all done later on, and there are ways to do it. Naturally, there could be always more resources that tell you how to do it, and maybe more findable resources. But this critical element is naturally the information loss that could happen in the meantime. And I would simply prioritize this aspect. And this is not changing that much, actually, in many cases. It's naturally evolving, but it's maybe longer process. So it could be somehow supported. And this is the basis of these curriculums, I guess.
All right. Thank you so much for that response. Washington?
Yeah, thank you very much, Leo. Yeah, my point was also probably first on the standards. Apart from WMO and maybe ISO and other organizations being slow in setting up standards. But also you realize that the challenge also that other bodies also are quickly setting up standards. So the challenge is, that standard setting basically takes a longer period of time. So sometimes you quickly set a standard, but then when you take it to the ground, then there was something that was missing, and then the consumption of that standard becomes a challenge. So that is one thing that basically it's a challenge, especially from WMO. I know that is where we are also sometimes going slow, and I know the research community always says that WMO, we are slow in setting up this standard. So that is basically one thing, and the process is that we really believe that before a standard is adapted, you have to send it out there to all the member states, and then they test. And for sure, when they test, you find there are always some gaps that sometimes it takes time to fix. But one of the questions maybe to the Geo Knowledge Hub is, especially we realize that the whole problem still revolves around these standards and basically showing the value of making the data available open. So the question is around what are basically the tangible benefits that we can really tell the data providers there that this is the reason of making your data open. That is one. And then number two is the standards are being developed, but what are how do we really want to help the data providers to really implement these standards? So this is also a question we are also struggling with here in WMO, because we have good standards, but the implementation is the challenge. We've not developed maybe some specific tools to allow the data providers to implement these tools, to implement the standards. So how does the team looks at how to help the data providers to really implement these standards, basically by thinking of maybe some basic tools that they could easily use. Thanks.
Is there anyone in the Geodata and Knowledge Working Group would like to give a quick response to that? Marie-Françoise?
So considering the implementation of the standards, I know that in the past, WMO, for instance, has co-developed and helped the development, supported the development of tools to produce the in-situ observations directly into the WMO standards. What I have seen also is when you have two communities that have different standards, for instance, WMO and NATO, or WMO and ICAO, each of them have their own standards because they are very big communities and they cannot follow the standardization evolution coming from the outside. So they need to follow the complexity of the world. For instance, WMO needs something like 10 years to change the standards because they have so many operational legacy systems in all the countries all over the world, and all the systems are so critical that they need a cycle like 10 years, meaning that they cannot change their implementations based on events that come from the outside, like a change of standards. So these big communities like ICO, let's take, and WMO have their own standards. And what can be done in between is translators, converters. And we have worked a little bit on that with the lib in-situ in a GEO environment. We provide on the Knowledge Hub a tool to help convert CSV, which is the most used format. I would not say, well, maybe standard, de facto standard, but it's not a good one to really reuse. And so we help convert, this tool help converts this format, which is very used, into NetCDF, which is more like a standard.
Thank you so much for that.
I answered your question, Washington.
Thank you so much for that response. I'll take the question from Alvaro and then we'll move towards closing because we want to keep seeing you in these dialogues.
Thank you, Leo. I would like to imagine this situation in the Amazon basin, for instance. The indigenous communities want to provide data about the contamination for mercury, just for illegal gold mining. Is there a mechanism to protect the indigenous communities? Because the illegal miners can threaten the communities because they know through the databases that they are providing, they are declaring that this contamination can be affecting the health or the environment in the local communities. I imagine it's difficult in this case. I have been the experience in the Amazon basin that some people are reluctant to provide data because they feel that they are weakened because they are exposed to the illegal miners and they know who provided this kind of information and could be retaliations against the communities. Is there any mechanism like disclaimers or something to protect the data providers in this case? Have you had some experience with someone?
Not direct experience, but I can respond in relation to the care principles that one of the considerations there is the authority to control, where you're giving those indigenous communities the right to control how data is shared. But beyond that, I don't have any direct experience. I don't know if Bente, do you want to respond?
Yes, I wanted to mention here, Alvaro, a new technology allowing control data sharing and even control the discoverability of the data. So and that's data spaces, and we have an action group in the EuroGeo working on that. And I just attended an international data spaces symposium where this is a global community working on this, technologies to manage that. And it sounds like this could be actually a good case that where you want to share data, but you don't necessarily want to share the information about the provider, not even even have control of who can discover the data. Sometimes that is actually necessary. Thank you.
Thank you.
Thank you. Yeah, and the next webinar will be about data spaces.
Exactly. Yes.
So please join us.
Stay tuned, Alvaro. Stay tuned.
I will be.
Marie-Françoise, do you have any other remark? Or sorry, I'm muted.
Yeah. As a contribution to the answer to Alvaro, I was just thinking that I saw some projects where the planes and the boats had a double naming to anonymize them. Then you could not know what type of boat, type of plane it was, for instance. In this case, anonymization, of course, is one and approach. And then the control of who accesses the data, as Bente said before, it's another approach. Is either out, I think.
All right. Thank you so much, all. We could do this all day, but we have to move towards closing. I would love to give thanks to all the speakers again, and thanks to Bente, Marie-Françoise, Kalamkas, and the rest of the GEO Knowledge Hub team in helping putting this important dialogue together. From my side, I think we hope to see you at the next one, and it's about data spaces.